Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Rasulil Kareem. Dear students, we were discussing about the solutions. Here are some another basic topics, small topics that you should understand for clearing your concept about solution. Here are they. The first one is soluble. The definition of soluble is that capable of being dissolved. A substance that dissolves in another substance is soluble in that substance, or the substance that is capable of being dissolved in any solvent. For example, NaCl has the ability to dissolve in water, so it is soluble in water. It is said to be soluble in water. Similarly, a substance that does not dissolve in another substance or any other solvent, it is known to be insoluble in that solvent. For example, oil is insoluble in water because when we put few spoons of oil in glass of water, it would not dissolve. Rather, uh, it will be spread on the surface and it will not dissolve in the water. So the oil is insoluble in water. Oil is said to be insoluble in water. There are few another topics that you must understand for learning about the solution. The first one is solubility, maximum amount of a substance that will dissolve in a given amount of another substance. Or in other words, the amount of solute dissolved in 100 gram of or 100 cm cube of another solvent. For example, if you want to check the solubility of NaCl, you take 100 gram or 100 ml of water and add sodium chloride in that water. Then you will note that maximum amount of salt dissolve in that water. A stage will come that no more salt will dissolve in the water. So just weigh that amount of salt and just check the maximum amount of solubility of salt in water. You have to find it at your home. Limits to the amount of most liquids or solid solutes that will dissolve in a given solvent. It means that there is certain limit. After that limit, no extra amount of solute will dissolve in the water. In simple words, there is limit of solubility of given or particular solute or solid in any solvent. You have to tell me, you have to check the maximum solubility or the limit of solubility of sodium chloride in water, that how much sodium chloride can be dissolved in 100 gram of water. Temperature and pressure can affect solubility. How? We will discuss later. Factors that affect the rate of dissolving. Rate of dissolving is different from the amount that will dissolve. Rate is how fast. Several factors influence the rate of dissolving. For example, temperature. Certain substances, the solubility of certain substances increases with increase in temperature and decreases with increase in temperature. In other words, there are few solids whose solubility decreases by increasing temperature, and there are other solutes. We will discuss the examples in detail in our book. So there are some other solids or solutes whose solubility increases with increasing temperature. Similarly, the second is stirring or agitation. What is agitation and what is stirring? I have told you in the lab, and I will tell you again in the lab, inshallah. By stirring, the solubility of some solute increases. Like, for example, if you add 2 spoons of sugar in a cup of water, it will dissolve. If you, let's suppose, if you add third spoon of sugar in that cup of water, it will not dissolve. But if you stir, if you shake that solution with a glass rod or any other means, that the extra spoon of sugar will also dissolve in that solution. Basically, stirring helps in increasing the kinetic energy of solute and solvent, helps in dissolving, helps in dissolution of solute in that solution, or in other words, increases the collision between solute and solvent. Similarly, surface area of solute, if you increase the surface area of solute, then the rate of dissolution increases. For example, if you add a pretty much large piece of solid piece of sodium chloride salt in water, it will take long time to dissolve in water. But if you convert that solid part or solid portion of sodium chloride into powder form, then it will readily dissolve within few minutes, because you have increased the surface area of the salt. Similarly, sugar in crystal form will take much time to dissolve in water, but if you convert sugar into powder form, into fine powder form, it will readily dissolve in the water. Okay. Similarly, amount of solute already dissolved. If you want to add, if you want to dissolve solute in that solution which has already large amount of solute, then you will face much difficulty in dissolving that solute, because there would be less space available in the solution for the incoming solute. Dissolving is basically a physical change. You can reverse, like if you had dissolved salt in water, you can reverse, you can separate salt and water. Inshallah, we will do experiment in lab of separating the mixture of salt and water. All the physical and chemical changes are accompanied by changes in energy. Equations for dissolving, like sugar is in solid form. If you add sugar in water, it will convert into aqueous form. It will dissolve in aqueous form. Similarly, sodium chloride is in solid form. When you add sodium chloride in water, it will convert into aqueous ions, that is sodium ion and chloride ion. Let's look at the picture. Sugar source and water, and in the solution, water molecules surround the sugar molecules, or sugar changes into aqueous form. Covalent substances dissolve to produce molecules in solution. The sugar is covalent substance, so it will dissolve to produce molecules in solution, and such molecules will be called as aqueous molecules, like aqueous sugar. Similarly, ionic substance dissolve to produce ions in the solution. Take an example of sodium chloride. If you add sodium chloride in water, it will convert into positive ions and chloride ions. Remember, let's say this positive ion would be surrounded by negative portion of water, and you know the negative portion of water is oxygen. Similarly, the negative chloride ion would be surrounded by positive portion of water, that is hydrogen, positive hydrogen, or in other words, positive hydrogen of water will surround the negative chloride ion of sodium chloride, and negative portion of water molecules will surround the positive sodium ions of the salt. Solvation. Interaction between the solvent molecules and the solute particle is known as solvation. Solute particles are surrounded by solvent particles in dissolving the process. We have discussed in this table that solute particles are surrounded by solvent particles, that is water. Solute particles may be ions, polar molecules, or non-polar molecules. Similarly, solvent molecules may be polar or non-polar. Hydration, specific name for the solute-solvent interaction when the solvent is water. Remember, when anyone asks you about the hydration, simple, say that any solute-solvent interaction when the solvent is water. For example, hydration of chloride ion. When you put sodium chloride in the water, the chloride ion will be surrounded by positive portion of water molecules. It is also called as molecule ion interaction or ion dipole interaction. Remember, ion dipole interaction. Similarly, if you add sodium chloride in water, the sodium positive ion will be surrounded by negative part, that is oxygen of water. The solute-solvent interaction must be greater than the interaction between solute particles for dissolving to occur. Like the interaction of sodium with negative part of water, or the interaction of chloride ion with positive part of water is much more greater than interaction between sodium and chlorine. So that's why sodium chloride dissolves in water. Solubility, amount of solute that will dissolve in a specific solvent at a given temperature and pressure. It is experimentally determined. Okay, it is experimental value, or in other words, amount of solute in grams dissolved in 100 grams of solvent. Okay, solubility traces for most but not all solvent have positive slope. The hotter the solvent, the more solute dissolves. This is the solubility curve for selected solids. Like if you increase the temperature in certain substances, the solubility increases, and in certain substances it decreases. For example, cesium sulfate. When you increase the temperature, the solubility of cesium sulfate decreases. Similarly, the effect of temperature on sodium chloride is very little. Similarly, the effect of increasing temperature or KNO3 is very greater. If you increase the temperature, more and more KNO3 will dissolve in water, more and more potassium nitrate and more lead nitrate will dissolve in 100 gram of water. Okay, whereas if you increase the temperature, the solubility of cesium sulfate decreases. Solubility traces for all gases have negative slope. Remember, if you increase the temperature, the solubility of gases decreases. Always remember. Why do fish like cold water? You have to answer this question, and the answer for this question is hidden in this graph. Okay, if you increase the temperature, the solubility of oxygen decreases, the solubility of carbon monoxide, methane, and helium, and all other gases decreases in water. Remember, if you heat the water, the solubility of gases decreases. Why do you see bubbles from the side of the beaker as the water warms up? Because the solubility of gases in water is inversely proportional to temperature. If you gradually increases the temperature of water, the dissolved gases in the water will evaporate or will convert into vapors or will convert into undissolved form, because the solubility of gases in water decreases with temperature. Okay, you have to learn also about the miscible and immiscible. When two liquids mix with each other, they are known as miscible. For example, water and ethanol are miscible in all proportion. Immiscible, liquids that cannot mix with each other. For example, oil and water are immiscible. Oil and water are immiscible. Okay, so just copy this flow chart. Matter can be converted into pure substance and impure, known as mixture. Pure substance is further divided into elements and compounds, and mixture is further divided into homogeneous and heterogeneous mixture. Homogeneous may or may not conduct electricity. Okay, Allah Hafiz. Thank you so much. Remember